All right, so these are 3D printed fraction tiles, and you have the hole, which you'll notice has a hinge on it. And the reason for this is so that you can actually put all these in a single container, because otherwise, if this was a solid piece, it would be pretty hard to fit in a cheaper container. So that's one. Then you have your halves, thirds, fourths, fifths, sixths, eighths, ninths, tenths, and twelfths. So most fraction sets do not include ninths. This one does, so that you can look at the relationship between thirds and ninths. All right, so I'm going to put these over to the side, and I'm going to show you a couple things you can do with this. So one of the things is you can use them on a number line to teach children on how to label fractions on a number line. So I'm going to make one hole here. All right. And I'm going to compare two fractions for this problem. I'm going to just compare, do 4/9 and we'll do 5/8. All right, so 4/9. I can start at 0. I can do the whole bit here. I can mark 4/9. If I wanted to, I could mark every single individual ninth here. Some children might need that. And then I said 5/8, so I'll get some 8s here. Maybe I should have done 3/8, but because that would have been a little less obvious. But you can see right here, 5/8 is significantly larger. Get that over to the 0 there. And just to kind of get a bead on where everything is, I'm going to put where the half marker is, because that's sometimes a nice indicator for students to understand where everything is in relation, not just to the 0 and the 1, but also the halfway point. And that allows for some very straightforward comparisons, so students start to learn not just where fractions are on a number line, but how they can partition a number line in that regard. There's a few other things you can do with fraction tiles. So one obvious one is to do addition and subtraction. We can do something as simple as 2/4. No, let's do 1/4 minus 1/8. Well, no, 2/4 minus 1/8. That might be a bit better. So if I were to take this away, I would actually need to be able to convert this into 8s. And you can lay these on top and make that conversion. If I'm doing that, I'm also going to write this on paper. So if I'm doing this, I'll be able to say 2/4 minus 1/8 is the same as 4/8 minus 1/8. And now I have this visualization of understanding that 2/4 and 4/8 are the same, because every fourth has 2 8s.